Friends, welcome to my next video. Here we will be discussing about different sampling techniques. So we will discuss about what is sampling, what are the related terms, what is probability sampling, different types of probability sampling with their relative merits and demerits, and also about non-probability sampling. So these will be covering in two lectures back to back. So let us start. To start with, let us first learn about some related terms involving sampling. First, we speak about the sampling unit. The constituents of the population, which are individual units to be sampled and which cannot be further subdivided for the purpose is called of sampling, that is called as a sampling unit. Keeping it very simple, it is somewhat like this. Suppose we want to study the households of a particular town. That means the socio-economic profile of the households of a particular town. Then each household of that town is a sampling unit. So each individual household is a sampling unit. Individuals are not sampling unit, because if you break down to the individual level, then the definition of household will not hold. So we are actually, since it is a household survey, so each individual household is a sampling unit. Now, if it is about students in a university, then each individual student is the sampling unit. If it is about the cattle that is grazing in a village field, then individual cattle is a sampling unit. So this way the sampling units keeps on changing, and it is the purpose of the survey which determines what shall be the sampling unit. Sampling frame is an exhaustive list or a map of all these sampling units. It may be in the form of a map, or it may be in the form of their identity, like their name, email ID, phone number, address, etc. list. A very common example of sampling frame is the voter list. The voter list is a sampling frame of all the voters, because it has detailed description of all the individual voters of that particular constituency or that particular polling booth. So that's why it is called as a sampling frame. So earlier, when there was landline in every home, then there used to be a telephone directory of that particular town. That means it consists under that particular uh, office, that is telecom office, all the people who are connected to landline through this telephone office, so telecommunication office, that was there in a book which is called as telephone directory. So that telephone directory is actually a sampling frame of all the people who are possessing a telephone. So these are some examples of sampling frame. And now let us go to sampling method. This is the method through which we are going to select the sample from the population. Since we have discussed about population and sampling in our previous video, so those who have not watched this video, I request you to watch this video to get a overview of what is sampling, what is sample, and what is population. So here we are speaking about sample methods, that from the population we are to draw the sample, and the method that we would follow, that comes as the sampling method. Some related terms in this context are the universe. The universe is the entire population, or all the members of the population that constitute my universe. And there is something called a sampling fraction, which is the sample size divided by population size. That is small n divided by capital N. That is the sampling fraction. Now let us look at the probability sampling and non-probability sampling. Now, in probability sampling, every unit has equal chance of getting selected in the sample. And so when you speak about a probability sample, each member of the population has a chance of coming into yours, appearing in the sample. The result obtained from this sample technique can be generalized for the entire population. So the result can be generalized. This is another issue. That means you can study a sample and generalize it for the population. That is, you can study a sample and tell in the sample we find that this is happening. So the same thing would also happen in the population. So that is the way we can generalize the results. This is possible when you are going with a probability sampling. As randomization is assured, so statistical tests can be applied in this particular case, because most of the statistical tests have a basic assumption. The data is randomly selected. So since in probability sampling the observations in the sample are randomly selected, so we can apply statistical tests in case of probability sampling. In non-probability sampling, it is just the reverse. the selection process of the units to the sample from the population is a call of the researcher. Researcher will take a decision whom to select and why she should select that particular. So it is not kept on probability, but it is somewhat deterministic regarding the selection of an individual from the population to the sample. Now, obviously, as the selector does so, it is highly prone to investigator bias. And since it is a biased sample, so the result cannot be generalized for the population. You cannot study a non-probability sampling and tell that this is what is happening in the sample. So the same thing will be happen to all the people in the population. You cannot generalize the results. Or in general, this will what will happen in the population. You cannot generalize the results. Rather, you can tell that, okay, this is what is happening in the sample. So this is what is happening in the sample only. We cannot generalize. We cannot take it further beyond the sample. So that is about non-probability sampling. Now, statistical tests are not recommended for if you are using non-probability sampling. You may find the values, you may find the proportions, you may find the percentage, you may find the average. That is fine. But statistical tests like ANOVA, t-test, f-test, and several other statistical techniques cannot be applied, because almost all the statistical techniques where tests are involved wants that your data should be randomly selected. Now this is called as the technique which is non-probability and does not believe in randomization, and so statistical tests are restricted. Use of statistical tests are restricted in this sample which are collected through non-probability sampling technique. Now let us look at some of the major probability sampling technique and non-probability sampling technique and study them one by one. First is called as the simple random sample. Then is stratified random sampling, then cluster sampling, systematic sampling, two-stage sampling extended to multi-stage sampling, and double sampling. So these are different types of probability sampling techniques. There are several others, but these are the main probability sampling techniques that we generally utilize in collecting a sample from a population. And there are some non-probability sampling techniques also. They are judgment sampling or purposive sampling, convenience sampling, quota sampling, and snowball sampling. So these are some of the non-probability sampling techniques. The simple random sampling. Simple random sampling is done in such a way that each individual unit of the population, that means each sampling unit is provided with a identification number, maybe serial number, and then through a random technique they are selected in the population. The sample size is determined beforehand, and from the population we determine those number of people in a random fashion, and they are identified the number. So we may select the number and then refer to those individuals who are having those numbers as to have been selected in the sample. So this is one method. Some people use lottery method. These days computer is used for drawing a simple random sampling. Now there are two types of simple random sampling. One type of simple random sampling has equal in case of simple random sampling, all the units have equal chance of occurrence. That means probability of everyone occurring in the sample is same. Now there are two methods. One is with replacement, one is without replacement. In with replacement, what we do, that we draw a sample, we note down in number and then replace it in the population once again. That means next time also when you draw, that particular element has a chance of getting selected. So it may so happen that an item gets selected more than once in a particular sample. It may also so happen that from a population of say size 100, you draw 10 observations in your sample and 10 of them are the same individual. There is a very small probability this will happen, but this will generally not happen. But there is a very small probability that this might be a possibility in case of simple random sampling with replacement. In simple random sampling without replacement, we select an individual and the individual who is selected in the sample is not returned back to the population. That means in the next drawing, this particular individual has no chance of occurring because the individual has already occurred. individual has already appeared in the sample. So there will be no repetition in case of simple random sampling without replacement. However, in each of the cases, the chance of an individual to get select in the sample is same. So that is a very interesting thing, whether you go with replacement or without replacement. So proof is there to it can be showed mathematically that the probabilities remain the same in both the cases, in case of simple random sampling with replacement or in case of simple random sampling without replacement. Now this sampling technique, when to use? We can use this sampling technique when population is more or less homogeneous. For example, suppose you want to do a social profiling on some slum dwellers. So you visited a slum, you want to collect a sample of observations or sample of households from the slum, and you want to do a socio-economic profiling, like how many members are there in the family, how many earning members are there, what might be the approximate monthly income, this type of things you want to do, what type of food they eat, is there any savings, if they save the money, where they save the money. This type of survey you want to do from in a slum. Now, in a slum area, what happens? You will hardly find any rich person there. You will hardly find a middle class people there. Generally, people in the lower, below poverty line, or just a little bit, maybe just above the poverty line. Those type of people are staying in slum area. So here the population is more or less homogeneous. In these cases, you can apply the simple random sampling. Or you want to study the fertility of a soil. Now the area is not very big. Area is a small area, few acres of land only, and it's a plain area. There is no change in the terrain in that area which you want to study. So it is expected that the fertility of the soil will be more or less homogeneous. So you take, whether you take soil from this part or from that part or from the third part, they are expected to give little bit same results. Means there is uniformity in the soil. In such case, you can use simple random sampling. So that is the concept here. And this technique requires that the sampling frame is available. That is a very important issue. That in case sampling frame is available, then only we can apply this particular sampling technique and find out the result. So sampling frame, list of all sampling units should be available with you. Let us take an example. So this is a small animation to tell what I mean to say. So suppose this is a population. There are several, these are all individual units. This is one sampling unit. This is two sampling units. So these are several sampling units in the population. Now from there we select randomly. We select by lottery method or by some other computerized method. We select these people. So we select the sample. So these people sampling units got selected. Whichever are having red mark, these sampling units are selected in my sample. So I draw them in the sample. So they are now joining the sample, and so this is the sample. So and accordingly, you see in the population, these units have vanished from the population because they are now members of the sample. So that is what has happened in my sample. So incidentally, it has gone out of the circle, but it should come here. So anyways, now if you look at the population, you find that these are missing, means they are in the sample now. You also observe one thing, that some of the areas are nicely represented. For example, if we assume that this is one lane, this is another lane, this is another lane, and some of the lane are overrepresented. Like this lane, 1, 2, 3 members are selected from this lane. However, from this lane, only one member is selected. And from this lane, the last part one, no one is selected. And from the fourth lane also, no one is selected. So that means some lanes are overrepresented, some lanes are nicely represented, adequately represented, and some cells are not represented at all. So this is one issue. Means if you see if this is a heterogeneous population, not homogeneous but heterogeneous population, then you see some of the groups, maybe rich people are more in number coming in the sample, and poor people are less number, or middle class people are less represented in the sample. So this type of things might happen, especially when these will happen more when the population start becoming heterogeneous. So that is one disadvantage of simple random sampling technique, that when the population start becoming heterogeneous, this sampling technique might not give adequate results or might not give good results. In such a case, What is the next step? Let us go to the next step. In the next step, what comes forward is a stratified random sampling. Stratified random sampling is a restricted random sampling. Here we not only have the sampling frame, but in addition to the sampling frame, about each unit we have some information. Once again, let us take the example that now I am going to a town. Instead of going to a slum, I am going to a town, and I want to make a similar type of socio-economic profiling of the residents of the town. Now, in a reasonable town, what we see around us in a reasonable, okay, town, there are people of different economic groups. There will be some very poor people who at night sleep in the footpath. There will be very rich people who can run or have or possess BMW and run their BMW through the people sleeping in the footpath. There are people like that also. And there are some people who can afford sleeping in their homes covered by four walls and uh, having a terrace over their head. So all different types of people are there. That means the population is heterogeneous. Now, for applying stratified random sampling, number one, we need to have a knowledge about the sampling frame. Number two, we are to have some idea about this name and phone number and email ID and address is not sufficient. We must have some idea about their income. Either I know which income group they fall or I have the numerical value of the income. A numerical value is best, but we often not have this numerical income. Is a very dicey thing. Even you cannot tell your income also because you might have some other sources of income beyond what your salary. So in that case, it will be difficult for you to know the income, but then you know the income group that these are super rich people, these are rich, these are upper middle class, this is middle class, this is the lower middle class group, these are poor people. You have an idea about the population. Now we will divide the population into some groups, not physically, but before drawing the sample, we will divide them into some groups like rich, upper middle class, lower middle class, and poor. And now after dividing the population into such groups, these groups are called as strata. There are some ways in which you can make the strata. Number one, or some characteristics you may tell of the strata. Number one individual or a particular sampling unit simultaneously will not be in two strata. Is either he is in poor strata or in middle class. Simultaneously, a particular individual both in poor and middle class not allowed. And all the units of the population will join some strata or the other. All the units of the population will join some strata or the other. मतलब कहीं ना कहीं इसको होना है. All the members of the population. Now we will randomly select. We will randomly select samples from each strata and get my final sample. So since the selection will be made from each strata, so every group of individual will be represented. So that is one very interesting thing about stratification. And you see now my sample will have rich people also, middle class also, lower middle class also, upper middle class also, poor also. Now I am satisfied with my sample. The sample is nicely representing the population. One aspect to remember that sampling needs to be heterogeneous, not homogeneous. It should represent the characteristics of the population. If it does not represent the characteristics of the population, then it will not give you the result you desire, and you want that it should generalize your result. You want that whatever is there in the population, that should be reflected in the sample. As this cannot be done, so we have to look into stratified random sampling. I have here some animation which will make the thing clear. Like we have proportional allocation. Proportional allocation means the number of units drawn from each strata. Number of units drawn from each stratum. Stratum is the singular, strata is the plural. Number of units drawn from each stratum should be proportional to the members. If in a particular strata members are more, then in the sample also more number of members should appear from that strata. Okay, now as you do it, you will understand. So these are some people say they are having different economic strength. Now I divide them as per their economic strength and I get a new picture of my population. So I take this, I keep it here. 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 I take the watercolored bubbles and keep this here. Now look at the different bubbles. Now you see, you understand that this is stratification. All the people are now in different strata. There is no particular individual who is simultaneously in two strata. And the members within the strata are somewhat similar. Members between the strata are different from each other. So that is the concept of stratification. Now I will draw the sample. How many from each strata? It will be proportional. Proportional means the strata in which number of members are more, I will select more number from there. And where the number is less, I will select less number from there. Obviously, the sample size will be smaller than population size. For example, by this time you have already understood that from these representation will be more because there are a larger number of members here. And from these also representation will be more because this is larger in number than this. So what we do, out of every two, we select one. So here 3, so we cannot select 1.5. So from here we select 2. Here 4 are there, I select 2. Here 6 are there, I select 3. Here 4 are there, I select 2. And here so many are there, I select half of them. Now you see my sample has everything. It has red dots, it has blue bubbles, it has red bubbles, it has watercolor bubbles, it has green bubbles, everything is there. Now my sample is adequately represented and every group is present there in the sample. So that will make the sample a more representative of the population. And some times there we go for disproportionate allocation also. Earlier example was a proportionate allocation. In disproportionate allocation, there are different factors on which the stratification depends. That strata where the variation is more, from there we select more number of members. Or that strata where data collection is very expensive, from there we select less number of members. And if the strata size is big, from there we might select large number. There are 3 criteria. That if the strata size is large, it means large number of observations are there, from there we select. That is actually a proportional allocation. That is a proportional allocation concept. Next we go for variation. That means variation means suppose in one particular area of your town, there is lot of variation. Rich people are there, super rich is there, middle class is there, और footpath में सोने वाले, those who sleep in the footpath, poor people, they are also there in that particular area. So from that particular area, variation is more, so we will select more number of members in that. Okay, and inversely proportional to cost. You see, cost is a very important factor. If an area is located far away, and for doing this you need to select a larger sample, then it will be very expensive for you. So such an area which is a very remote or a strata, for example, rich people, it may be difficult to collect data from them because they don't have time. And then even if they have time, they don't like to talk to you. Even they like to talk to you, they cannot take a long survey. They will tell that, okay, jo bhi hai, jaldi jaldi khatam karo. I have other work to do. So maybe you have to spend a lot of time collecting information from that. So instead of taking a lot of people, rich people, you may tell less number of rich people, because so that this allocation disproportionate allocation, it is sometimes also necessary, this technical thing. Okay guys, now thank you for watching. We will come with the next volume very soon. Thank you.